We are going to be talking about the properties of tangent lines today. So there's a fill in the blank in a couple of these spots in this first little paragraph. It says a blank is the set of all points on a plane that are equidistant from a given point called the blank. So this is a circle is the set of all points in a plane that are equidistant from a given point called the center of the circle. A circle with a center P is called circle P. So whenever the point in the middle is named, that's what your circle is named. Okay? And can be written as a little circle with a point in the middle, P. So this is our notation for a circle right here. Okay? A segment whose endpoints are the center and any point on the circle is a radius. So your radius goes from the center to the edge of the circle. Right? A chord is a segment whose endpoints are on a circle.
Still
Yes. And a diameter is a chord that contains the center of a circle. So over here they have all those things labeled that we were just talking about. So this point right here, that is what we refer to as the center, right? Your radius has to go from the center to the edge of the circle. So our radius would be any line going from the center to the edge. Okay? A chord just has to touch your circle with both endpoints. So this is a chord. The line has its endpoints on the circle. And as we know, our diameter is a chord that has to go through the center. So its endpoints are on the circle, but it also has to cross through the center, right through the middle. Okay, so some of those are review vocab like radius and diameter. Some of these are new terms. Okay. All right, so another new vocabulary word we will be adding is tangent. A tangent is a line that intersects a circle at exactly one point. For example, over here, that would be the line RU in this picture. So this line RU touches the circle at exactly one point, that point T. So this line is what we call a tangent. Okay? Next word is a point of tangency. This is the point on the circle where a tangent line intersects the circle. Okay, that would be in this figure like point T. Alright, so your tangent is the line that touches the edge of the circle the one time. Your point of tangency is the exact point where it touches. Okay? Right? Then we have common tangents. Oops. What's going on? Hold on. There it goes. Okay. So common tangents. This is a line that is tangent to two or more circles. So that would be like either of these pictures here. You can see that the line is tangent to circle S and C because it touches each one of those circles once. Here, also tangent to the circles S and C. It touches each one of those circles one time. Okay? Alright, then within common tangents we have these two types. So the internal tangents are the ones where they're intersecting between these two circles. So your tangent line goes between the two circles. While your external tangents do not go between the circles. So we've got tangent lines and points of tangency. Those tangents could touch more than one circle. And if they do, then they are called common tangents. They touch between the circles, internal, outside, external. Okay? Alright, so then we have some theorems here. Okay? So the first theorem says if a line is tangent to a circle, then it is perpendicular to the radius drawn to the point of tangency. So the converse of that would also be true, that the radius is perpendicular to the tangent. So in this picture, the radius is ST, and it's perpendicular to the tangent, RT. Okay. And they are perpendicular at point T. Alright, so we now know that a radius and a tangent are going to be perpendicular, meaning they form a 90-degree angle. Our second theorem says if two segments from the same exterior point are tangent to a circle, then they are congruent. The converse would also be true. So, what they're talking about is these are coming from some external point V, and both of the lines that come from V are tangent to your circle. They're saying that means that these two line segments have to be congruent. From V to T would be congruent from V to R. Okay, so we can use both of these ideas to help us find missing angles or missing side links if we're trying to figure out how long one of the tangent lines is. Okay. All right, so let's flip it over on the back. And it says we're going to look at this figure over here to answer these questions. Okay, so first it says that they are looking for a tangent to circle C, but not tangent to S. So which line is only a tangent for circle C? So what makes it a tangent? Right, it can only touch the circle at one point. So which one of these lines only touches the circle at one point on its edge? Point R, what line does that come from? S. So the line segment SR is going to be tangent to this circle, but not this one, right? Because it went inside the circle. It touches the edge of the circle one time, just like it did here, right? If it goes into the circle, eventually it's got to come back out, and then it's going to be touching at two places, so it's no longer tangent. Okay? So tangent can only touch the edge of the circle one time. Okay? So segment SR is going to touch circle C once, but it is not tangent to circle S. Okay? All right, now they want us to find one that is neither, so it's not a tangent for either circle. SC, very good. All right, now we're looking for a common external tangent. PQ, right? So that one does not go between. Good. Yes, and our internal would be T. Is it T? What is it? A. A. All right. Okay. So now that we know how to identify them, if we're given a figure, let's use those ideas to help us find some missing segments. Okay. So it says circles T and R are tangent at point Q. QW and SW are tangent to circle T. Circle T has a radius of 24, QX is 5, and XW is 11. So we're going to go in and label the pieces that they actually gave us. Okay, so first they said that circle T has a radius of 24. Okay, well a radius goes from the center of the circle all the way to where? The edge, okay? Right? So all of that is 24. Or from T to S, 24, right? If it goes from the center to the edge, it's 24. Okay? Alright, they said that QX is 5. So that would be this little segment here. And XW from here to here is 11. Okay, and we're supposed to be finding all of these other pieces, right? Yeah.
Is this supposed to be circles T and S?
T and R. Remember, you name a circle from the letter in the center of the circle. So the big circle is T. This smaller circle has R in its center. So circles T and R. Okay, so then they ask, how long is QR? Well, the radius goes from T to Q, right? Which is half of the circle. But that also goes all the way from one edge of the circle to the other. What do we call the line that goes all the way to the middle? Diameter, right? So the diameter of our small circle is 24. So what would the radius of the small circle be? 12. So that piece would have to be 12, and so would that piece, right? It's cutting it in half. So QR would have to be 12. Okay? All right, then they want to know QW. Right, because we would just add those two segments together, right? We just add 5 plus 11. All right. Then they want to know TX. We already said TS would be, because it is a radius. Good. Okay. Then they want to know line segment RX. Okay, so that's going to go from the point R to the point X. Okay, so that's not going to be just within one circle so that we can call it a radius anymore, right?
Yeah.
Okay, but we said that if we have a tangent line, it's what with a radius? What is it going to form? Perpendicular, so it forms a right angle. Okay? And we said that this piece is 5 and this piece is 12. How do we find the missing side in a right triangle? Pythagorean theorem. Right. So we would have 5 squared plus 12 squared equals that line that we're looking for, c squared. So 25 plus 144 is what? Okay, yes, so we would take the square root. This piece, c, must be 13. Very good. Okay, so Rx is 13. All right, then they ask, what's the length of SW?
16.
16, right? Because we just had a theorem on the front page that said that if they came from the same external point, those two lines should be congruent. So if the other one is 16, so is that one. All right? And then lastly, they want RW. Okay, so R all the way to W. Well, again, we know we have a 90-degree angle, right? Okay, so what's this side length? 12, And what's this side length in that right triangle? 16. So if we want to find the hypotenuse, we just do Pythagorean theorem again, right? So what do we get when we square these in half then? Huh? Yeah, well, we get 400, and then we take the square root, which, yes, is 20. All right, so we were able to find all those missing pieces using only those two rules, that we know we have right angles, and that the if they come from the same external point, they are congruent. Okay. All right, example 3 says that triangle TRW is circumscribed about circle A. If the perimeter of triangle TRW is 50, TK is equal to 3, WM equals 9.5, and they want you to find TR. Okay, so we did not introduce this vocab word on the front, but circumscribed means all sides are tangent to the circle. Okay, so in this figure, the triangle is saying all of its sides are tangent to the circle, meaning it touches the circle one time, right? Okay, so then let's go ahead and label what they gave us. They said TK is 3, oh, they have it, and WM is 9.5, so now we need to label what we know to be true. So, let's start with TK. What do I know that TK should be congruent to? TL, right. So, that would mean that side TL must be 3. Okay, so now I know this piece is 3. Alright. Then we know WM. And what should WM be congruent to? Okay. So, MR should be, okay, so now I know this piece over here is 9.5. Oh, sorry, not that piece over here, 9.5. We should have said WK, right? Sorry, I didn't correct you all when you said it. But remember, it's the points that come from the same external tangent that are here. So it's those two pieces, right? Now, over here, our external point is R. So whatever these two pieces are, they should be congruent, right? We just don't know what they are. But we might set something else up to solve for it, okay? So, they said that the perimeter of this thing is 50, and we know all the other pieces, so we should just be able to take out the other pieces and see what's left and divide it evenly amongst those two pieces, right? So I'm just going to call those two pieces x for now. We don't know what they are. Okay? And how do you find the perimeter of something? Add up all the sides. So I would have 9.5 plus 9.5 plus 3 plus 3 plus x, right? Okay? So I would have, what is 3 plus 3 plus 9.5 plus 9.5? Huh? 25. Plus these two x's is equal to the perimeter of 50 that they gave us. Okay? And then we just solve for x. So 2x is equal to 5. So what is x? Good. So we now know that LR, because it's congruent to MR, must both be equal to 12.5. Okay. All right, we got one more. Okay, it says line M is tangent to circle A at the point B. Find the radius of the circle. Well, where does the radius go from? Center to the edge. Okay, so it's going to go from point A to point B, right? Okay, so I'm basically just trying to figure out how far it is from one point to the next on a coordinate plane. We have a formula for that. All right, we have our distance formula, square root of x2 minus x1 squared plus y2 minus y1 squared. And we just need to plug in the correct values. All right. Okay, so if we're going to find the radius, like you guys said, we're looking for the distance between points A and B. Okay, so what would our x2 be, or our x value for point B? 1 minus, what's our other x value? Squared plus y2 minus y1 would be squared. Good. All right, so 1 minus 3 would give us -2, and -2 squared would give us, okay, and -1 minus 2 would be -3, and -3 squared is +9. So I have 4 plus 9, which is 13 underneath that radical. Okay. They did not specify how they want their answer, so we can leave it just like that. Okay. Alright, so they said to find the slope of line M. Okay, well, first of all, I should just be able to remember that my radius is what to that line? Perpendicular, right? And I can easily count up and over from point B to point A, right? Because I know exactly where they are. How much do I have to go up and over to get from point B to point A? Right. So our slope for the radius is 3/2. And if those lines are perpendicular, what do we automatically know should be the slope for M? -2/3. And since perpendicular to M, slope